During their school years, pupils solve hundreds and hundreds of tasks where they have to perform the calculations and in the end write the equal sign and after that the value of their calculations. From their experiences, children construct the operational meaning of the equal sign. After that comes the answer. But if this is the only meaning they have for the equal sign, they will be in trouble when starting to study algebraic equation solving. They have no possibilities of understanding the reasons behind. And I think that at this level, many mathematics teachers just give up for this reason. They just teach the methods, how to solve linear equations, and not attend the reasons behind. And as a consequence of this, children experience mathematics as meaningless activity.
We have done some research on the topic in the University of Lapland. My colleague Pieti Tolvanen is preparing his doctoral thesis in my supervision. He's interested in the development of algebraic thinking in the early grades. Pieti collected his data between autumn 2018 and autumn 2020. The result I'm presenting to you in this video is obtained from a test delivered to 454 fifth graders in Rovaniemi. The research of Pieti is still in process, and these are only preliminary results. In this bar chart, you see the percentages of fifth graders in the data who gave different answers to this same equation we have been discussing. Approximately 52% of the pupils gave the right answer 7, conveying the use of the structural meaning. This is not a bad result compared to other studies done elsewhere in the world. The following 3 bars represent answers 12, 17, and both 12 and 17. These answers convey acting according to the operational meaning of the equal sign. Together they make up 42% of the answers. In 6% of the answers, there was some other number or no answer. In our earlier pilot tests, we saw that when pupils enter from primary school to lower secondary school, still a big portion of them answer according to the operational meaning. But during the 3 years of lower secondary, grades, meaning grades 7 to 9, a percentage of using structural meaning increased clearly. That may be because they start studying algebra in the 7th grade. In this diagram, we see the distribution of answers to this task in 28 classes. The pink bars represent the proportion of the right answer, 7, and the blue, green, and purple parts together represent the answers according to the operational meaning. What is striking to me is that the proportions differ from class to class very much. There are 3 classrooms where almost all the students answered 7, but there are around 10 classes where only approximately 1/3 of the pupils answered according to the structural meaning. Because Finnish classrooms are all heterogeneous, the main reason must be the teaching the pupils have encountered. And this brings hope the teaching really matters. You can influence this phenomenon by quality teaching. Let's have a look at two types of equation solving. The first is arithmetic equation solving, and the second is algebraic equation solving. They are based on different underlying principles. I used to work in a Nordic Californian videomat project where the beginning of algebra studies was investigated in Norway, Sweden, Finland, and California. In the Finnish data, equations were solved in 3 classrooms in the 6th grade. These are the types of equations that pupils were taught to solve. In all of them, the letter symbol x appears in the other side only, and it appears there only once. In the other side, there is only one number, and this number can be interpreted as the answer. The operational meaning of the equal sign is enough to be able to solve these equations. For example, if you look at the third equation, 40 minus x equals 23. It can be solved by thinking which number must be subtracted from 40 so that the answer is 23. These are so-called arithmetic equations, which can be solved by using number facts and knowledge about operations and inverse operations. And as stated, the operational meaning of the equal sign is enough to be able to work in this context. If we look at the equations, the first equation, x plus 7 equals 23, can be solved by subtracting 7 from 23. X equals 23 minus 7. The second equation is solved by adding 5 to 18. X equals 18 plus 5. And the third equation, 40 minus x equals 23, is now suddenly solved by subtracting 23 from 40. So x equals 40 minus 23. Two subtraction equations, both solved in different ways. The first by addition and the second by subtraction. In practice, pupils had to memorize a different method for solving each of these equations. I don't say it very sensible, but this is how it used to be in Finnish math books for 5th and 6th grades a while ago. I think things are changing now, and pupils are better prepared to meet algebraic equation solving. The algebraic equation solving is applicable to all linear, meaning first order, equations, including those where the letter symbol x is found on both sides or found several times. The letter symbol x must be interpreted to vary, to go through different values. When x gets different values, also the values of the left-hand side and right-hand side of the equation vary. For some x values, the left side and the right side may have the same value. Those x values are the solutions of the equation. For other x values, the values of the left side and the right side are different. Those x values are not solutions of the equation. In algebraic equation solving, we perform the same operations to both sides of the equation, and they have to be so-called allowed operations. For example, in this case, the first operation performed to both sides of the equation is subtracting 2 times x from both sides. The new equation 2 times x plus 2 equals 6 has exactly the same solutions as the original. This is so if you use the allowed operations. Finally, the last equation, x equals 2, has exactly the same solutions as all the previous equations. And x equals 2 is the solution of the original equation. This process is based on the idea of both sides of the equation having the same value for all the numbers we call solutions. It is not possible to understand the process with the operational meaning of the equal sign. Instead of asking pupils to memorize 6 different methods of solving arithmetic equations, I think it is more sensible to prepare them little by little to encounter the algebraic equation solving. That idea is being promoted in more recent study materials for elementary schools in Finland. Helping pupils understand the structural meaning of the equal sign is part of that work. Another important topic is the concept of the variable.